Yeah, Dr. Ram, welcome for today's podcast from the Foundry side. Just to brief you off, so Founders is a premium finishing school and deep tech venture school. We are located in Hyderabad as well as in Warangal, and we have four different kind of school of thoughts, which is school of deep tech and sustainability, energy, and entrepreneurship. And inside school of deep tech, we pretty much, head the research, especially in the field of AI, cybersecurity, quantum, blockchain, and robotics and IoT also. And today is a very, happy for us. We are inviting you, such an honored guy who's been doing a lot of research in the field of physics, and we would like to get your perspectives, insights on the quantum computing revolution, what is happening in the industry, and which is very much related for your background. So again, welcome once again to the today's session, and it's an honor for us. Yeah.
Thank you.
So yeah, yeah. So, Ramgar, do you want to go ahead and introduce yourself to the viewers who are going to pretty much view this off?
Okay. Those who don't know about me, that I'm Dr. Ram Soorat, of course, and I completed my PhD in 2015 from University of Hyderabad in quantum information. There I have
Yeah.
worked on something called BB84 protocol. Okay,
Mm,
so
mm,
my entire PhD work is on BB84 protocol. And then after that, I moved to my first postdoc at Soorat University. There,
mm-hmm.
basically, I have worked on this how we can excuse the, pulse and make it for quantum application. So it's
Oh,
called phase sensitive amplification. So
okay. Okay.
and then it's a kind of collaborative work between
Mm, mm,
France and India. So it's
mhm.
under something called CPIPA project.
Okay. Okay.
So I used to go to France for doing experiment and doing analysis in India. So this
Mm,
is how this is my first postdoc. And then after first postdoc, I moved to one of the very famous institute called Indian Statistical Institute, that is in Kolkata.
ah, yeah.
So yeah, there I was working on entanglement. If you have some
Mm,
entanglement,
mm,
and
mm,
if you want to, how this entanglement works, if you do
yeah.
change in one side, then how this second one get disturbed. So I have worked
Mm,
on that one.
mm,
That paper is also there in archive. You can check it. Then
mm,
after that, I moved to IIT Delhi.
mm,
Uh, so there I have worked on differential phase shift based quantum key distribution. This is another
mm,
protocol for
mm,
quantum key distribution. And we have done a lot of work over there. Then I got an opportunity to serve as a chief scientist in Abu Dhabi.
uh-huh.
So,
Nice.
so I was working very closely to design and build a hardware device for security region towards bank.
Mm, mm,
So, my expertise, since my expertise is experimental, and from PhD onwards, and whatever I have gained knowledge in during my postdoc experience, these
mm-hmm,
all are
mm-hmm.
mostly hardware based. So it's like uh, combine all together is all about security. So means
Okay.
security, when we are talking about security and all, then we have to first part is discussed to randomness. So
Okay.
we have
Yeah.
uh, here at Abu Dhabi, and I
Mm,
was working as a chief scientist. We have built a very good team with researcher and all, and we got so much fund also.
wow.
Uh,
Mm,
uh, we bought instrument, we tested, and
mm,
there I have done this quantum random number generation,
mm,
and
mm,
we are moving to fabricate for commercial purpose. So it's like
yeah.
USB is there, right?
Mm-hmm.
So we can. we can put that USB in our system, and instead of generating pseudo-based random number, we can generate quantum random number.
Mm.
So we are
Mm.
about to finish that task, but that time Corona comes
Yeah.
and
Yeah.
things got disturbed.
Okay.
Most of the people got disturbed with that. And then I'm back to India, and then I taught 2 years in University of Delhi. Uh,
Okay.
for postgraduate student.
Mm.
From past 3 years, I've completed
Mm.
3 years at Woxsen University here in Hyderabad.
Oh, wow. Wow.
And here I'm teaching to BTech student, uh,
Mm.
and I'm very lucky that I got a chance to guide so many students. So
Nice.
nearly 80 plus student working towards quantum technology at Oxford University.
Wow.
So yeah, some of the students they publish paper, they publish
Mm.
patent,
Mm.
they are now submitted multiple paper
Mm.
on quantum technology. So here basically, since whatever I have experienced gained earlier, that
Mm.
was hardware based. But here now, since we don't have hardware at Oxfam now, we are in that process. Maybe in
Mhm.
couple of
Mhm.
month or year, we are going to purchase some hardware based equipment and set up for quantum technology based lab. So here
Mm.
I have focused on software. So this is called quantum computing.
Wow.
So
Okay.
I started learning quantum computing
Mm.
because communication is different, computing is
Mm.
different.
Yeah.
Altogether is called quantum information. So
Ah.
basically, quantum information has two parts. One
Mm.
is we can say distribution, one is computing. So
Yes.
distribution means information sharing from one place to other
Mm.
place. Computing means within, the system you have to do all the algorithm based whatever decision is there. So you can do that.
Mm. Mm.
So I'm working on quantum computing,
Mhm.
and here I'm also training to a student towards quantum finance.
Uh-huh.
I mean, so nowadays most of the people who has money,
Mm.
they they used to fall in the stock market.
Mm.
Everybody who have money, mostly because things are getting very easy. Stock market is getting very easy. It is
Mm.
early. It was very difficult to get access for a stock market, but now this is very friendly. I mean, so anybody can sit in home and get the credential, log in it, and put the money. But the worst part is that if you don't have knowledge, you are going to lose.
Mm.
So
Mm.
so here at Oxford University, I'm training to a student that how we can predict the stock market. What are the sentiment? What is the market sentiment? When is going to be up? When is going to be down?
Mm.
So we are writing our algorithm
Mm.
and testing, doing the back test,
Okay.
and I'm hoping by December this year we are
Mm.
coming up with our own algorithm, our
Mm.
own indicator, which can determine this market. I mean,
Mhm.
predict market somewhat accurately.
Mm.
I mean, say in
Mm.
market, if you can predict 50%,
Yeah. Yeah. Yeah.
it's a huge, and fifty
Yeah.
percent is a kind of like common for anyone. I mean, you can say that okay, this is going up, this is going down, but
Mm.
it's not happening,
Yes.
right? So these
Yes.
kind of work I'm currently doing quantum
Okay.
computing
Okay.
towards quantum finance. So this
Yeah.
is what
Got it.
all about my journey in this field. So I mean, from PhD onwards, this is like 18 years. I'm in
Mm.
quantum information. I must say I'm
Wow.
in quantum information. I have not debated from my topic. Yes. Yeah.
That's very fantastic. And you worked as a chief scientist, and you did good number of experiments on this particular distribution as well as the computing side. So, uh, when you were talking about the entanglement, right? So,
Yes, yes.
as per Sir Einstein, he pretty much talks about the spooky action when there
Yes,
is an
yes.
entanglement happens at a particular distance. How do
Mhm.
you So how do you think that perspective can enlarge the research what we have to do, or put these quantum algorithms for the betterment of the society or anything else? So do we think we can really solve that with the given hardware, with the given infrastructure what we have?
Uh, See, when we talk about entanglement, so
Hmm,
first we have
hmm.
to understand what is entanglement
Okay.
and what are the infrastructure required for this one. Do we have those infrastructure or not?
Yes.
Are we going to some more time to take to make this thing happens?
Hmm,
So entanglement is a kind of mathematical magic.
hmm, hmm.
Okay, it's kind of, we can say it's a kind of magic. So in
Okay.
the
Okay.
so we used to watch in our early days some movies where
Hmm.
in movies there's a twin brother or twin sister is there. So we can
Yes.
take
Yes.
twin as an
Hmm,
example.
hmm,
And in movies we used to see that if one fellow is suppose is in Hyderabad, one is in Delhi,
hmm, hmm,
and one fellow did some kind of crime. Let's say
hmm,
Hyderabad fellow is doing some crime.
hmm,
Then and they catch to this Hyderabad, beaten him.
hmm.
And who is there in Delhi, that fellow is also feel the pain.
Yeah.
These kind
Yeah.
of action we have seen in movies.
Yes. Yes.
So what are the connection between these two, twins?
Hmm,
So these connection,
hmm,
if we can say that how they are connected. So there is some kind of connection is there.
mm-hmm,
Okay.
mm-hmm,
Now when we comes into the quantum entanglement,
hmm,
so we used to do something. I mean, we used to generate.
hmm.
Okay, so we used to generate this entanglement particles. For entanglement, you need require minimum two particle.
Okay. Okay.
So here, if we go somewhat more technical form, can we go in more technical form?
Please, please, please. This is all the forum
Because
about talking about more technical.
yeah,
Yeah. Yeah.
yeah. So if you go in more technical form, then it's required kind of BBO crystal. Okay,
Hmm.
some kind of crystal which is a high intensity laser. So what is happening, this whatever comes that laser along with some twin photons generated. Okay,
Hmm. Hmm.
this is what you can check it in my paper also. So I have done this one. So you have a two entangled photon, and if you
Hmm.
measure the property of this one,
Hmm.
okay,
Hmm.
then what is the property of this one? You will easily understand. So
Hmm. Hmm.
no matter what are the distance between these
Hmm.
two particles, if you measure this particular party, you know what is this.
Okay.
Okay. So before measurement, you don't know what is happening. Let's say let's uh, put it in other way. Suppose you have a classically, if I'm talking about this one for understanding, I'm just trying to make it somewhat
Uh-huh.
easy.
Yeah.
Let's
Yeah.
say you have a sleeper. Okay,
Hmm.
so one is left leg, one is right leg, right?
Hmm.
And I put it into a box,
Hmm. Hmm.
and I send one box to, let's say, Delhi.
Hmm.
So if you measure Delhi fellow, okay, and he got the right one, automatically he knows that you have a left one.
Hmm. Hmm.
Okay, but here what is happening? Classically, if you change that one, nothing will happen here. But
Hmm.
in quantum mechanically, if you change
Hmm.
one
Hmm.
particle, this other fellow will also get changed. So these are the magic. They are
Hmm.
connected. This quantum mechanically, they are connected. Kind of magical correlation that
Hmm.
when no matter what are the distance between these two, if you put it in, one is on Earth, one is on uh, any moon, and if you
Hmm. Hmm.
change there, it will also get changed. So this is what the uh, entanglement concept. If you go deeper, and it's quite interesting. It's quite
Yeah.
interesting.
Yeah. I mean, like the way you
And
are
this,
explaining is also very interesting anyway.
so this is very much nowadays useful for communication. I mean, if
Mm-hmm.
you generated entangled photon, and if you change here, if you want to add some information, you have added here, let's immediately change that state, and that fellow is also got the information. So quantum entanglement is now useful for communication part. So this is what the Einstein and they are talking about this thing.
Okay, okay. Is this something really which does about the wave dual particle, something like that with that, or else is it purely electron based one?
Uh, see, so here I think see, this is if you're talking about entanglement purely electron based or photon based. So of course we have I said one way generating of entanglement is optical way. We can take lasers generate to entangle
Mm,
photon.
mm,
So
mm,
this is happening.
mm,
But
mm,
the most interesting part for these are the basic part for this quantum computing.
mhm,
If
mhm,
we're talking about this one. So
mm.
I think before entanglement, we should know about what is quantum computing part.
Okay, okay.
Okay. So, and what is the difference between what are the computer we are using and
Yes.
what this and what is quantum computer? What is the difference between these two?
Mm,
So
mm.
honestly speaking, what I understood from this classical computer, I have used quantum computer also, IBM quantum computer.
Nice. Nice.
I'm using it from very long time.
Mm,
Uh, Anybody can use quantum computer, uh,
mm, mm,
which is sitting in IBM headquarters. So
mm,
the difference between these two is actually uh, between to understand this. This our computer is only understand two things.
mm,
Either there's a signal, there's a no signal, right?
mm.
It's
Yeah.
on or off. Or
Off.
we can say
Yeah.
it in mathematical form: 0 and 1. Something
Yes.
is there, nothing is there.
Nothing is.
This
Yeah.
so this computer is working on based on that, and
Mm,
later on this uh, you know if we are typing some kind of information, so that is converted into 0 and 1, and corresponding is analysis this that we
mm,
used to call that CPU does this processing, and accordingly it's give the outcome.
mm,
Quantum computer is slightly different,
mm,
and
mm,
one more thing that whatever classical computer is doing,
mm,
quantum
mm,
computer is also going to do the same, but that is for uh, betterment of things. Betterment of things means we are not going to do this 2 plus 2 addition with quantum computer. For that,
mm,
classical
mm.
computer is there.
Yeah.
So
Yeah.
we are going to use this classical computer
Mm,
to, you know, for complex solving the problem
mm.
and writing this code and all, we are going to use classical computer to use this quantum computer. So
Okay.
quantum computer understand only that is something different we used to call qubit.
Yeah. Yeah.
So qubit is, of course, it's a 0 or 1.
Mm,
And then what are the possible combination is there between 0 and 1?
mm,
So anything, any value it can be. So we
mm,
used to write the something called superposition.
huh,
Okay,
mm,
like so this is works. Quantum computer works on the principle of superposition,
mm.
and superposition is something which is not in kind of static mode. Static mode in the
Okay.
sense like you have a coin.
Yeah.
Okay,
Yeah.
so for coin you have a head and tail. So
Yes.
if
Yes.
suppose you have a coin which is sitting on your table, so you can look at that and you can say that it's a head or tail.
Mm, mm,
But what will happen if I rotate this coin?
mm.
So what will you say? It's a head or tail?
50-50.
50-50. You
Yeah.
don't know how you're
Yeah.
going to write this.
Mm.
Classically, you cannot write even,
Yes. Yes.
but quantum mechanically, you can write this in
Mm.
terms of
Okay.
superposition. So
Mm.
this superposition got the n number of information.
Mm.
And this is the reason,
Yeah.
because it's between 0 and 1, it can be anything. Okay,
Yes.
that's
Yes.
why
Yes.
this superposition, we used to write the information for quantum computer in terms of superposition. And
Mm-hmm.
this superposition is has the n number of probability. Okay. And that's why this our calculation is going to be more accurate and fast.
More
So,
accurate. Can you
quantum computer works on superposition principle. Yes.
got it, got it. Can you explain the superposition without using any complicated mathematics or any other stuff so that the listeners or viewers they can understand it very easily, right?
So this is what I said about this superposition. You have a coin, you
Hmm.
toss it, you toss
Hmm.
it.
Hmm.
So if you measure this, you will get either head and tail.
Hmm. Hmm.
And
Okay.
if I
Hmm.
ask you,
Hmm.
what is head or tail in air?
Hmm.
So what
You
is
have to
your
say
answer?
something. You have to pick it something. You have to
S-
pick
That
something.
that one we used to call superposition.
Hmm.
Head
Okay.
after after this measurement, we got
Yeah.
this head. After this
Yes.
measurement, we got tail.
Hmm.
But what
Hmm.
is there? I'm asking that. What is the probability of head in the air?
Again, the same
You cannot
50-50.
say.
Yeah, we
You
cannot say.
cannot say.
Yeah.
But you can write it. Classically, you
Hmm.
can't write, but you can quantum mechanically you can write in terms of superposition. So
Hmm.
superposition is something like head plus tail by root 2. We used to write like that. So that is called
Hmm.
superposition.
Okay.
That is very
Okay.
interesting, and that
Yeah.
makes quantum computer, to work in different way. Yeah.
Got it. Got it. So as we've been talking about this, we are talking about the measurement and all this. So
Mhm.
people also often talk about the Schrodinger's cat
Mhm.
explanation. And can you explain that experiment little bit of basically to understand
So,
the measurements and all that?
mhm.
Yeah, yeah.
So Schrodinger cat is this is also like if you take a cat,
Hmm.
put it poison inside,
Hmm.
and I put a box.
Yeah,
What is the probability of cat life?
we don't know still.
What is the
Like
probability of cat died?
when it is poison, obviously it will die.
But that is inside the box.
Yeah,
So how you are going to write? This cat is live or dead?
cat is dead.
We don't know.
Hmm.
So how we are going to write? That is in terms of superposition.
Okay.
Live
Hmm.
plus dead by root 2. It's called
Live plus
superposition
dead by root
by
2.
root 2. So that is actually basically it's a one example. Let's see, most of the things are in superposition state. When we are
Hmm.
not, we are. Second thing is that this classical is giving you a exact. When once you measure this one, you will get exact a
Hmm.
value. But in quantum mechanical, with the same system, if you measure 100 times, you'll get 100 different value because this output of quantum system is always in probabilistic nature.
Hmm. Hmm.
Yeah. So that is the thing.
Okay, but the same thing happens even with the artificial intelligence in the current scenario, right? I mean, like when I pass out a query, I'll get the different set of results. I mean, like all these servers which are running right now, if we put it in such a way, all these are the classical systems, right?
Uh-huh.
So when I put a query and when somebody else puts this, query, they
Uh-huh.
get the different results and I get the different results.
But the
So
same
do you
algorithm.
yeah, backend it will be the same algorithm which runs, right? So
Mhm.
do you think even inside the classical computers also we have some level of superposition things are working off? Or else is it only the
No,
distribution of the information?
no. See, basically what is happening, what you are getting, maybe that is because of some error.
Hmm. Hmm.
Okay. This is quite possible. But
Hmm.
with classical system, always you will get the exact answer. If
Okay.
it's in quantum, you will get different answer with the same system.
Okay. Hmm. Hmm. But how do you
So
calculate that error?
the calculating this error, suppose you have a system with classical system, and you have some error. So there is some algorithm behind that. So based on
Okay.
that, you can calculate the error.
Okay. And also parallelly, can we manipulate the states of these calculations in the quantum side?
See, when we are talking about quantum, then
Hmm.
manipulation and all these things is a different story. It's become
Hmm.
different story because suppose we are doing some kind of calculation,
Hmm.
okay,
Hmm.
and we are using this classical computer.
Hmm.
So in classical computer, what is happening? We wrote the algorithm,
Hmm.
okay, and based on the algorithm, we put the value,
Hmm.
and then accordingly is giving the outcome.
Hmm.
But
Hmm.
then when it's come to quantum thing, then
Hmm.
what is happening? We have to write quantum algorithm for that,
Hmm.
which is
Hmm.
something called post-quantum cryptography we used to call. So
Hmm.
post-quantum cryptography is also can be done by using this classical computer only. But way
Hmm.
of writing this
Hmm.
algorithm is something different. It's not like classical algorithm. We cannot write like a plus b whole square. This is kind of algorithm, right? So
Yeah.
it's valid
Yeah.
for classical computer, but we
Hmm.
cannot write this a plus b whole square for quantum computer. So that is converted where
Hmm.
the information is going to read for qubit, not bit. Remember here,
Hmm.
qubit.
Hmm.
And the qubit has, I mean, if you are working on this one, qubit is work on like classical computer, how
Hmm.
it's working. We used this register, transistor, etc.
Hmm. Hmm.
We made it here. Okay.
Hmm.
And for quantum computer, we used to gate, see, for classical, we used to gate. Is gate like AND gate, OR gate, NOR gate, etc.
Hmm.
For
Hmm.
quantum computer, gate are different. We are using gate only, but that is
Hmm.
different.
Okay.
That is theta naught gate, C
Hmm.
naught gate,
Hmm.
okay, CC naught gate, Pauli gate,
Hmm.
okay. There's a
Hmm.
multiple gate is there.
Hmm.
So let's say, for example, if we are writing some kind of algorithm, then we convert if algorithm is there. So we have to write algorithm which can read qubit, not bit,
Hmm. Hmm.
qubit. And reading this qubit, this gate are helping. So
Hmm.
like you have a zero qubit, you want superposition, pass through a
Hmm.
Hadamard gate, you will get superposition
Uh-huh.
and do the
Uh-huh.
calculation.
Hmm.
So this is something different. I mean, so you have to write the different,
Hmm.
algorithm. And
Hmm.
based on that, if you are doing the calculation, if you are
Hmm.
doing simulation, of course, you are going to get the kind of exact answer
Hmm.
because simulation will give you. But if you are using quantum computer,
Hmm. Hmm.
then every time with the same system, with the same algorithm, it'll give you some slightly modified. Like for example, to better understanding, like 2 plus 2 is 4.
Hmm.
Okay,
Hmm.
so if you run 1,000 times with classical computer, it'll give you 4.
Hmm. Hmm.
But if you run this quantum computer,
Hmm.
I'm just see quantum
Yeah.
computer is not for meant for this 2 plus 2, but I'm telling you just to
Hmm.
better clarity to understand that
Hmm. Hmm.
this will give you 3.9999
Hmm.
or 4.0001111 something. It will give you some value.
Hmm. Hmm.
So it's a kind of close only. It's not going to give you too much difference.
Okay. Okay.
Yeah.
So
So that is.
what does really changes when we, really use these quantum computers at
Mhm.
the production level at the industry? What
Mhm.
changes more? Is it accuracy? Is it reliability? Or else is it efficiency? What happens really?
Okay. See, for this, I must say one thing is that quantum computer is meant for complex problem.
Hmm. Hmm.
So when you're going to be in, very microscopic level, atomic
Hmm.
level, we can call it,
Hmm.
or you are doing some calculation in 10 power something minus,
Hmm.
not plus.
Hmm.
Okay.
Hmm.
Then this classical computer will give you some error.
Hmm.
Like for example, nowadays this is very much useful in medical side, medicine.
Hmm. Hmm.
Medicine, this quantum computing helping a lot.
Okay. Okay.
So whatever calculation let's say, for example, paracetamol is there.
Yeah.
So if before coming to real use, there
Hmm.
is so much, research going on. Maybe
Hmm.
it takes 10 year, 15 year, 20 year like that.
Hmm.
Why? Because uh, that paracetamol is given to some kind of first animal, then slowly look at the behavior of that one, and then it came to a human body.
Hmm.
Okay. So this calculation, whatever calculation involved in this one, because we used to
Hmm.
do calculation at atomic level.
Hmm.
So nowadays, that calculation which is done for like let's say 10 years to
Hmm.
produce one medicine for real use.
Hmm.
Now, this is become very much easy. You can do it in some few months also by using quantum computer. So it's a very complex. It's quantum computer do very complex analysis, accurate also.
Hmm.
Okay,
Hmm.
if we are going in that one, and
Hmm.
efficient and faster. So
Hmm.
that is the answer for that.
Okay. Yeah, got it. So, jumping into the algorithm side, because we've been
Mhm.
discussing about those kind of a stuff. We have spoke about the quantum gates and
Yeah.
comparison of the classical versus the quantum and good stuff. So now if we go a little bit into the algorithm side, so
Okay.
one of the algorithm which has been noticed by the world, which is known as Shor's algorithm, right?
Yes. Yes.
So
Yes.
yeah. So why did
Mhm.
it send those kind of shockwaves basically in the cybersecurity world?
Cyber security word. Uh,
The applicability of the Shor's algorithm, why did
uh-huh.
it make so much of noise exclusively in cybersecurity side, saying that this is where it can be applied, this is how it can be applied, and everywhere, wherever you go, I mean, like since we spoke about post-quantum cryptography also, every single person who is in the industry,
Mhm.
they, keep talking about this Shor's algorithm. Can
Yes,
you
yes.
just dumb it down little bit about understanding about this Shor's algorithm?
So when see basically this Soar algorithm and Grover algorithm
Hmm.
that we
Hmm.
use it for prime factor and Grover is for search. Okay,
Okay.
Soar is for prime factor.
Hmm.
So like suppose we are using this ATM pin
Hmm.
that is a 4 digit, right?
Hmm. Hmm.
So you have given some number.
Hmm.
So if I give to uh, classical computer,
Hmm.
can it some number? My
Hmm.
passcode is this. So can it guess that what is this? It will take lot of calculation. It will take year to
Hmm.
calculate.
Okay. Okay.
But by using this Grover algorithm,
Hmm.
okay, we can do it easily. We can say that because it's easily do this prime factor analysis. So
Got
it's
it. Got it.
easy to do. So easily guess that one. And
Hmm.
second thing is that see how this classical computer. If you have some task, you
Yeah.
give it to this one classical
Hmm.
computer.
Hmm.
So what
Hmm.
it will divide and goes one by one.
Hmm.
Do
Hmm.
this one, this one, this one. Okay, but this quantum computer, since this works on different, this is called superposition.
Hmm.
So it say classical, it will open one by one. Okay,
Ah. Yes.
but
Hmm.
quantum, it will open at a time, and it's
Hmm.
exactly pick the your exact number. And
Hmm.
this is the reason that see uh, nowadays we are using this OTP, etc.
Yes.
Right?
Ah.
So
Ah.
that comes from seed, some kind of software.
Hmm. Yes.
And if we put that, suppose you got the OTP, if you put
Hmm.
it in quantum computer, it will give
Mm-hmm.
you the algorithm. Okay,
Hmm.
and if I
Hmm.
know the algorithm, I can predict that this is what is going to be the next OTP for your transaction.
Okay. Okay.
So So that way, this SOAR algorithm and GROWER algorithm, now
Hmm.
this is very much popular for quantum
Hmm.
information research.
Got it. Got it.
Yeah.
Yeah. So if we were to, draw some lines of boundaries
Mhm.
between the theoretical and the practical advantages in the quantum area, where do you think
Mhm.
we have to draw the boundaries?
So drawing line, if you are asking that in which sense?
I mean, like there is so much of theoretical research which is going on, right?
Yeah, yeah.
Right? And there is so much of practicality is also going on. But
Yes, yes.
again, yeah.
Mhm.
So what is that line basically? So to convert this heavy, for example, let's say if you have 1,000 kgs of theoretical work to
Yes,
be
yes.
converted into the practical way, so how
Okay.
much time it will take and what is that boundary? Why are we,
Mhm.
designing those boundaries literally?
Yeah, this is really a very good question.
Hmm.
I can understand.
Yeah.
But actually these two, theoretical and experimental, both are helping us.
Hmm. Okay.
Okay, and we are like both are helping each other.
Hmm.
So everyone has their own pros and cons.
Hmm.
Okay, so like for example, uh, currently whatever information is going,
Yeah.
whatever we
Yeah.
are using, all these through is classical world. All
Hmm.
the communication is going through
Hmm.
classical world, all the OTP, all our security region, everything is going classical world. And
Yeah.
this is the region
Yeah.
that most of the fraud used to happen. Okay,
Hmm. Hmm.
scientists are trying to make it secure by using some kind of algorithm or some kind
Yes.
of theoretical research.
Hmm.
Now that we used to call this post quantum cryptography.
Hmm.
Okay,
Hmm. Hmm.
so that is one way, but we also parallelly require this hardware-based device to
Hmm.
perform for quantum computing stuff as well as our quantum distribution, our communication. We used to call communication. So that
Hmm.
both are needed. Yeah.
Hmm.
So they
Okay.
they are helping each other.
Hmm.
So of course, most of the thing is going to be make safe and secure by using because we are in physical world.
Hmm.
So this hardware-based things are going to be uh, make things more safe and secure. But
Got it.
of course, theoretical research is also needed to
Hmm. Hmm.
verify it.
Yeah.
The whatever practical is happening. So
Hmm.
that
Hmm.
yeah.
Wonderful.
So
Wonderful. Yeah. So for the students, for the learners, for the viewers who is listening to this podcast today, pretty
mhm.
much, what would be the career advances or career guidance would you give to them? And how does the
Mhm.
landscape pretty much look for us? And what kind of roles they can expect in the job economy for the future and all that? Yeah.
Uh, See, the biggest problem is in India.
Hmm.
What I observe is
Hmm.
that quantum stuff is mostly this basics we used to call it quantum physics.
Hmm.
So that
Hmm.
quantum physics is teach to only physics student,
Ah, okay.
and algorithm and writing this software kind of stuff is teach to technology student.
Hmm.
This is the biggest problem actually.
Hmm.
And what we need is quantum information, and quantum information is needed quantum technology plus your algorithm.
Hmm.
So physics people don't know algorithm, how
Hmm.
to write this algorithm, because we
Hmm.
learned something uh, like how these atoms behave, how this
Hmm. Hmm.
microscopic electrons behave, photons behave.
Yeah. Yeah.
But how we can use the application, because now
Hmm.
people are talking about this, how we can use this photon for our application purpose, make it
Hmm.
quantum communication stuff happen, or make it quantum computer stuff happen.
Hmm.
So what I suggest is that if you are a technology student,
Hmm.
learn some basic. Okay, because you are going to learn this Python, I mean software stuff. of course, but learn this quantum physics, at least what is qubit, how to make this qubit,
Mm.
all these things. And who is physics student, they should also learn how to write, how to do coding, how to write
Uh-huh.
code in Python. So if
Mm. Mm.
this kind of are, if government is providing such kind of uh, kind of interdisciplinary course, because see, like I have already proposed here in our Woxsen University to at least include one course for quantum computing
Okay.
for BTech
Okay.
student, because
Mm.
since we are teaching BTech, so we will
Mm.
start from quantum physics and slowly goes to quantum computing, how this quantum computing is understood, this quantum physics and making sense in it. So in
Mm.
that way, if you learn this like quantum information stuff, then there's a multiple job nowadays.
Mm.
Look at
Mm.
see, our Indian government itself has generated something like $1 billion, some 8,000 crore under the National Quantum Mission.
Mhm, mhm.
Okay, so there's a lot of opportunities there. If you look at here in Andhra Pradesh, Amravati,
Yes.
it's going to be big, you know, things in quantum information area. They have a
Mhm.
lot of job available. In Bangalore is there. Is
Mm.
Bangalore, I mean, Karnataka government is doing a lot of thing towards quantum information. Our Hyderabad also is going to involve. There's a multiple company also.
Mm.
They're looking some expert in quantum who can understand the quantum behavior
Mm.
in physics point of view and coding stuff also. So
Got it.
you can be, it's based on your interest whether you want to be a software engineer in quantum
Mm.
field or you want to be a hardware engineer in quantum field. If you
Mm.
want to be a software engineer, so of course you have to learn this Python, etc., with along with this quantum physics, how this
Mm.
photon behaves. Okay, all this
Yeah.
to understand this one. And
Mm.
if you are a physics guy, you have to learn Python and all this kind of language to
Got it.
write this code for your
Yeah.
this.
Yeah.
So there's a lot of opportunity as a software engineer in quantum information, as a hardware engineer in quantum information, as a quantum material engineer. I mean, because this one is hardware is coming, then of course we need some kind of material which is very much applicable for this quantum stuff. So quantum
Mm.
material
Mm.
and quantum sense in these four area is very much dominating in quantum field, that you
Wow.
can based on your expertise your and based on your desire that okay, I want to be the this kind of job. So there's a lot of job available.
Okay. Okay.
Even some of
So,
my students, they got this offer in some companies who learn
wow.
here. Yeah, yeah,
Nice.
so
Nice.
I'm very happy with
Fantastic.
that.
Fantastic. Fantastic. Yeah. Thank you, Dr. Ram. That was a very, good insights what you have provided for the futuristic students and the future job roles, and your guidance will be very valuable. And you have taught us few of the technicalities today about the superposition, comparable study of the, the gates and all that we have studied. And it's wonderful catching up with you. And thank you again. And it's an honor for us pretty much having such an great contributor for the physics world and especially in the quantum world, and who has did the great research in this particular field. And again, thank you very much for your time, pretty much. And take care.
Thank you for having
Yeah.
me here. And I'm very happy. Even in fact, in future, if anybody wanted to, involve in this quantum information area,
Yeah.
and they need any kind of help, please you can mention my contact number, better email ID. So
Sure.
rsurat@gmail.com, and I will try my best to help them. Thank
Oh,
you,
sure, sure. Wonderful, sir. We
thank
are
you very
looking for
much.
that kind of a cooperation to happen. And thank you again very much. Yeah.
Thank you.